Each role in proof of justice has a similar core nature. There are certain criteria and restrictions that must be met in order for an entity to validly initiate a role-related action. For example, the entity must have a valid score and in some cases may need to complete a challenge. Additionally, restrictions may be placed on the entity according to its score, such as its roles level if implemented. In cases where more than one entity is needed to cooperate in order to render a role-related action valid, a combination of restrictions may be used. The requester role is a default role in every proof of justice implementation and allows a given entity to create and push a transaction to the network according to multiple criteria. A requester always refers to another default role called a partner, which is responsible for validating parts of a transaction and providing its Peterson to the requester in order to include it in the transaction. Alongside the baseline criteria, one additional criteria appropriate for this role could be that the requester must not have done more than a determined number of transactions of one or more specific types in a determined number of previous blocks. In one implementation, this number could be a proof of justice parameter, while in another it could be calculated using the average of transactions of those specific types done by other entities in a determined number of previous blocks. Moreover, alongside the baseline restrictions, some appropriate restrictions for the requester role could include the number of assets the requester is able to transfer according to its requester level, a sum of transferred assets over time, and the like. In order to create a valid transaction, the requester needs to gather some pre-transaction information, which generally comprises an identifier of the requester, the assets to transfer, an identifier of the entity receiving those assets, and nonce, and the like. In most implementations, the pre-transaction information will also include the Peterson of the requester. Once this data has been gathered, the requester signs it, creating a signed pre-transaction. Before we continue, it is important to understand the concept of transaction fees. There are generally 5 possible types of transaction fees in proof of justice: feeless, adaptive, static, type-based, and dynamic. The feeless transaction fee type does not require the requester to pay any fees in order to create and push a transaction to the network. This is possible mainly because of the scoring system, the Peterson mechanism, and the block generation process. The block generation process will be explained in the next video. The adaptive transaction fee type requires the requester to pay a variable fee in order to create a transaction. As such, a transaction would be feeless only if certain conditions are met. These conditions may include the score, such as the level of the requester, a challenge that the requester must complete as part of the pre-transaction information gathering process, and any other conditions that are deemed appropriate based on the implementation. The static transaction fee type is a type that requires transactions to have a static and unchanging fee. The fee could be, for example, a very low amount determined as a proof of justice parameter. The type-based transaction fee type is a type that requires different types of transactions to have different fees. For example, one type of transaction might have a fee of 1 coin, while another type might have a fee of 10 coins. The specific fees for each type of transaction are generally determined as proof of justice parameters. The dynamic transaction fee type is a type that is calculated dynamically according to the fees of transactions in a determined number of previous blocks and specific conditions. These conditions can vary greatly based on the implementation and may consider, for example, the requester level, the size of the transaction, or any other conditions that are deemed appropriate. Now that we understand the different transaction fees, let's dive into how our requester would finish creating its transaction. In order for a transaction to be considered valid, a Peterson obtained from a partner must be obtained and comprised in said transaction. To do so, the requester would first select a partner using the entity selection process mentioned in a previous video. Then, the requester sends the partner a message comprising the signed pre-transaction information. The partner, after receiving the message, will do 2 things. First, it will generate its own Peterson using the Peterson generation process mentioned in a previous video. Then, it will validate the message and its content. The validating process will vary greatly based on the implementation. In most implementations, one important part of the validation is to evaluate the distance between the requester Peterson and the partner Peterson. To do so, the partner would use the Peterson tracking process mentioned in a previous video to determine the distance in blocks between the requester Peterson and its own Peterson. As such, if the distance is above a determined threshold, then something may not be right, and the requester may be acting maliciously. If everything is fine, the partner will then include its Peterson into a second message, sign the message, and send it to the requester. According to the implementation, the second message may contain additional information, such as the hash of one or more relevant portions of the first message. It is then determined if there is a need for one or more other partners for the transaction. This can be done based on various conditions, such as the requester's level, by looking at the number of punished requesters over a determined number of previous blocks, by the requester upon getting a recommendation from the partner, by a proof of justice parameter, or any other condition relevant to the implementation. If it is determined that the transaction needs another partner, then one is selected using the same process as for the first partner. The entity that performs the next selections will also vary greatly according to the implementation. In one implementation, the second partner may select the next one. In another implementation, it may be up to the requester to select its next partner. The process is then repeated for each new partner until it is determined that the transaction has gathered all the required partners, or until a maximum number of partners has been reached. The partner selection process can be much more complex based on the implementation of proof of justice. If you are interested in learning more, we invite you to take a deep dive into the requester and partner section of the Proof of Justice white paper. Once the necessary partners have done their duties, the requester compiles the data, adds the one or more partner Petersons to the transaction, signs the transaction, and broadcasts it to the network. The way entities that receive the requester transaction process, it will vary greatly from one implementation to another. For example, if an entity believes the transaction is malicious, it could report it using a system similar to the entity reporting system mentioned in a previous video. A transaction caching mechanism could be used to speed up the process of validating transactions. This would allow specific entities with a validator role to validate a transaction and provide a signed proof of validation to the network. Other entities in the network would then use this cached validation verdict instead of validating the transaction themselves. However, if a given entity doesn't trust the result of the cached validation, it can validate it manually. If the obtained result is different than the cached one, it would then be possible to report the cached one using a system similar to the entity reporting system mentioned in a previous video. Validators would also get allocated block rewards for their work, much like generators, enforcers, and other relevant roles. BB Inventions, high-tech research for curious minds.